Yeah, hello everyone. I'm Vijay Reddy, Assistant Professor, Department of ECE and KG Reddy College of Engineering and Technology. And today I'm going to discuss about microprocessor microcontroller subject, and that the second chapter we will discuss here 8051 microcontrollers. Yeah, everyone might know about this 8051 microcontroller, which is invented by Intel Corporation in the year of 1981. Earlier, Intel only developed the basic and standard microprocessor like 8085 and 8086, which in turn will perform all the logical or computational analysis only, but they do not have any extra or other peripherals. But why we are moving to the microcontroller, and what are the advantages of microcontroller over microprocessor? Let us discuss in detail. Before going to that, let us have a small conversation on what are the various features of microcontroller. Yeah, these are the various features you have listed here. 8051 microcontroller, it is having internal memory, whereas in microprocessor it doesn't have any internal memory, but microcontroller 8051 have internal memory. Yeah, you can see this. It's have ROM, random access memory, or the permanent memory of 4 kilobytes, and it is a temporary memory is a RAM 128 bytes. And similarly, one of the basic feature of controllers are like having ports where you can interconnect to multiple external devices and communicate with the system directly. So here 8051 microcontroller having total 4 ports of each 8-bit size, means as it is a 40-pin chip, the 8051 microcontroller is a 40-pin chip. So out of 40 pins, the 32 pins are divided as 4 ports, each port name as like port 0, port 1, port 2, port 3, and each port having its own functionality that we'll discuss in detail later on sessions. And another important feature of 8051 microcontroller is it is having two 16-bit internal timer counters built into the same set of chip, where two 16-bit timers are counters. They work as a timers to calculate all the internal timing analysis or delays, and they also acts as a counters to count external events. And it is also having the serial interface, that is UART, where it can communicate with external world using serial communication. And it is also having 64K external memory for code and 64K external memory for data can be accessed. As 8051 is a 8-bit microcontroller, it is having 8 data lines and 16 address lines. As it is having 16 address lines, that gives 2 power 16 is equal to 60K, means 60 kilobytes of external memory can be accessed, and total 210 bit addressable register operations you can carry out using 8051 microcontroller. And apart from this, you can list out few more advantages of this is like it is having a 16-bit program counter and data pointer registers, which helps to show next instruction to be executed and external data or memory operations. And the additional features of 8051 controller is along with the serial communication device UART, it is also having ADC and some sort of op-amp to perform various other applications or features when you develop a system using 8051 microcontroller. Okay, yeah. Now we'll discuss in detail why we have to choose 8051 microcontroller or microcontrollers over microprocessors. Let us see the various advantages of microcontroller system compared with microprocessors. Yes, as the microcontroller is also having peripherals on a single chip. If you just imagine microprocessors for 8086 or 8085, it is just a processor can perform various sort of operations, but when it comes to this developing a system or an application, you need to interconnect multiple other integrated circuits and external input output devices. So for that you need to use some sort of interfacing circuits also. So why? Because it is required interfacing circuits, because the compatibility of chip and the compatibility of other input output devices, we have to cross check along with their electrical properties. Okay, but whereas in 8051 microcontroller, as it is having a built-in peripherals, so that to developing of an application or the system is very easy, directly can interconnect input output modules without requirement of any extra chips, means other interfacing circuits. And the size of microcontroller is very small, which is as like same as microprocessor, but it also includes all the other extra peripherals. And designing of system using microcontroller is very easy. or simple, whereas microprocessor based system is complex enough. As I told you, we need to use more number of other extra peripherals and components. Yes, microprocessors as built-in peripherals are there, and the system complexity is reduces, and then the physical contact, physical connections is already made available within the chip itself, so it is very reliable or more reliable compared with microprocessor based systems. And also microcontrollers additionally having internal memories like RAM, ROM, and other input output ports, which in turn makes the system design very easy, and having internal memory of the system will provide security to the internal data. The RAM, ROM, which are both are built into a single chip of controller, and the ROM on chip ROM provides a software security. Likewise, we have lots of advantages of microcontroller based system compared with microprocessor based systems. And why are we choosing a microcontroller? Yes, we can have a lots of points on this, right? Because nowadays the computational needs and the cost efficient and size required for the system to develop, like there are so many factors, even the power supply usage and the developing of system, and noise generated by the module itself, and then tools available, the software tools available to develop the program application for the particular processor controller. Likewise, we need to remember, or we need to choose lot of points. Based on those lot of points only we can choose a particular microcontroller which is suitable for our system or application development. Yeah, now let us go with the detailed internal architecture or block diagram of 8051 microcontroller. Yes, this figure depicts the internal structure or architecture of 8051 microcontroller. Yes, we can easily understand how the structure was designed. It's very easy to remember. As I discussed, 8051 microcontroller having 4 ports, each of 8-bit size. The 4 ports we can show here. As you can see, port 0, port 2, port 1, port 3. Yes, the ports are arranged as like even ports one side, odd ports one side. It is very clear. You can understand from the pin diagram of 8051 microcontroller, where each and every port along with the pin functionality will be explained later. Okay, so the 4 ports are aligned here: port 1, port 3, port 0, port 2. And then along with this, as we discussed, it is also having internal memory. Yes, organized as RAM 128 bytes, then RAM address register, which will generate address locations of RAM for various data accessing purpose. And also we have the internal memory, that is the ROM or flash memory is there, which is used for permanent storage of data or program, whatever. And we have an accumulator register, A register, and another register, B, is a general purpose register. A register is called as accumulator because almost all the operations carried out by the ALU or edge of a microcontroller uses A register as by default register. That's what A is also called as accumulator, and register B is another operand register used here. And we are using 2 temporary registers, which will always useful for the purpose of storage temporary data before going to perform any sort of operations. Okay. And next, ALU. Yes, everyone knows that is ALU, which perform arithmetical logical unit. Here we can think as ALU is nothing but simple microprocessor, which we learned earlier, like 8085 or 8086, like a kind of thing, where it can perform all the set of computations which we have written in the form of assembly language programming or any other high level language programming converted into machine language. Next, yeah, as we discussed this same scenario in the case of 8086 microprocessor. Yes, PSW, program status word, it is also used to show the status of 8051 microcontroller execution for every instruction. Okay, I think how many of you remember the various flags which we learned in the case of 8051 microcontroller and 8085 and 8086 microprocessors, right? So 8085 and 8086 microprocessor we already learned previous classes. Now we are discussing about 8051 microcontroller. Let us have a small comparison between these two, like flag registers. If you see 8086 microprocessor, we have out of 16-bit size 9 flags we are using, but when it comes to microcontroller, out of 8 we are using only 5 flags. Yes, Yeah, how many of you remember what are the different flags are available in the case of 8086 microprocessor? Once you recall what are the different flags we discussed in 8086 microprocessor, I'm giving you 1 minute of time. Think and recall the concept of 8086 microprocessor flag register, which we will discuss in here also as same as for 8051 microcontroller. Now your time starts now. I think yes. I think everyone got idea about what are the different flags we learned in 8086 microprocessor. Yes, out of 9, a few flag registers or flags we are going to discuss in the 8051 microcontroller also. Now let us recall this. What are the different flags we learned there and now which are reflecting in the 8051 microcontroller? Yes, as 8051 microcontroller having only 5 flags, they are carry flag. You know that the same which we discussed there in the case of 8086, and auxiliary carry flag we have, and we also have parity and overflow. These are set of flags we are going to discuss here. If you compare 8086 and this, that zero flag won't be available in the case of 8051 microcontrollers. Okay. Yes, we'll discuss in detail about flag register and its functionality of each and every pin in detail in later on sessions. Right. Next, here the two different blocks which are in dark blue color, that is timing and control. In general, it is an oscillator circuit. An external oscillator provides the clock signal required to the controller to perform all the set of operations. Basically, the clock signal will be generated like this: external oscillator signal divided by 12, which divides the particular frequency required for microcontrollers or microprocessors. And next, another important topic of 8051 microcontroller is interrupts and serial and timer. Yes, even we discussed in the case of 8086 microcontrollers also. Interrupts, basically here in the case of 8051 also, they are hardware interrupts. We have hardware interrupts here, two different hardware interrupts we have: INT and then NMI, non-muscle interrupt, and INT are there in the case of 8086. Here we will discuss two external hardware interrupt, INT1 and INT0. Along with that, we have set of software interrupts. Okay, what do you mean by interrupt? Interrupt is a signal which just wakes up the controller or gives the information to the controller. Some other device or some other peripherals want to communicate with you or want to access your resources, or want your permission to execute a program or run a task, like that. It is like kind of information or signaling which gives information to the microcontroller to access the resources or the ALU of the microcontroller. And serial port and timers we will discuss in detail. We have a set of special function registers called timer mode control, power control, and serial control and serial mode control set of registers. We will discuss in detail about timer and counter operations there. Yes, next move to the stack pointer. Yes, we have a stack register 16-bit size and a stack pointer. Basically, the stack register and stack pointer together, they work for a stack operation of 8051 microcontroller. What do you mean by stack operation? Means when interrupt service routine occurs and the controller is going to execute or the ALU is going to execute that interrupt service routine while executing another program. What it does generally, it will store current execution program address location onto stack and goes to the interrupt service routine, and once interrupt service routine is completed, it will come back even it will come back to this the address location stored in the stack, which is the address location of previous program, which in turn should continue the same set of operations. Okay, here the stack pointer uses to show that current address location where you have to store the data before going to interrupt service routine, and similarly that address location of data or the address location of the current program stored in the stack, which in turn retrieve back to the ALU for further continuous process. Okay, and next we will move to this program address register, which will show the current status or the instruction of program where it is executing. If there are a set of instructions in the program, then for each and every instruction, the instruction pointer will be incremented by 1 and goes to the next level of instruction where it shows the current instruction to be executed. The program address is also same, where it will show all the address locations of the instructions or the code words stored in the program. And buffer register used along with this UART for serial communication. UART serial communication process through input devices. And program counter, yes, it will also shows that next instruction to be executed. It will store the next instruction to be executed by the controller. Yes, program incrementer and counter together both are work for to store and continuous process of next instruction to be executed like this. And the data pointer, as I told, it is a 16-bit register divided into two 8-bit registers of DPH and DPL. DPH and DPL, both it can work as a 8-bit register or it can also work as a 16-bit register. And this data pointer register is used in a few cases of addressing modes to access the data from external devices. Instead of using internal memory and internal available data, if you are performing an operation or certain applications which in turn communicate with external memories, then that time the data directly will not copied or accessed by ALU into the temporary registers. First it will be accessed into the data pointer to the temporary registers, and then can perform this various set of operations or applications. Yes, and along with this we have set of other features here. You can see program store enable, address latch enable, external access and reset pins. Yes, we know that reset pins is once you click that it will give a 5 volts pulse signal, which in turn resets entire system operation. And external access gives permission to access the external memory. Whenever you interconnect external memory, as we know that it can access a maximum of 64 KB of data or 64 KB of program memory, then to access the data or program memory from external chip, you must have a permission. That permission will be given by this external access. Active low in this pin will show this external memory will be accepted. Next, ALE address latch enable or program store enable. It is used to demultiplex the bidirectional multiplexed address and data buses. As like 8086 microprocessor, 8051 microcontroller also having 8 multiplexed address and data lines. To demultiplex them as address and data operation separately, we can use ALE as a pin. And program store enable. Yes, this again in turn used to communicate with external memory for storage and accessing of program and data purpose. Yes, this is about complete architecture and the internal structure of 8051 microcontroller. I think every one of you got idea about this. Everyone understood each and every block of 8051 microcontroller and how it works. Each and every block of microcontroller works. Thank you.